Alright, here we are on the milling machine and we can see the work in the vise. We got the cutter in already. It's a 12mm 3 flute router cutter. I think it's a 45 or something like that degree angle. It's a carbide cutter. Of course it's in our ER40 collet to 30 international taper. Okay, what we're going to do is we're going to cut some little pockets out here and then turn it over and do the same on the other end. I'll just show you, when I'm on this side of the machine you see me messing with things, something on the right hand side here. What I'm actually doing is I'm operating the low and the high range lever here on the gearbox. Where it is now is in low range. Pull it across, it's in high range. So if it's low range, it's there. And that gives me sufficient resistance to allow me to undo the nut here and take the cutters out. Also as well, this is the original clutch handle here. And there's a limit switch on that which ties in with the inverter drive and the control panel behind. So the normal operation would be when it stops, what I would do is I'd push that back and I'd put it into the low range gear. That makes sure nothing can start. There's actually a brake on the input shaft on the gearbox, which that lever connects to, so it acts as a brake as well. It's just a bit of a safety feature for it. You don't want to have this start on you when you're messing around with cutters and stuff. It'll rip your hand to pieces. But anyway, what we're going to do is we're going to just touch off on here. We're going to zero out on the DRO, and then we'll put a cut on and we'll just feed it in by hand. And I'm going to move you around to the other side of the machine so you can see a little bit better. So we'll just move you around. Alright, we've got you set up there, so you can see I've zoomed you in. Make sure you've got your safety glasses on, you're a bit close to the cutter here. This will throw chips everywhere. So what I'll do is I'll move my tray to that side, I'll catch the stuff in there. And what I have to do on this machine is, because it's they're a horizontal machine with a vertical head, I don't have a free floating quill or a quill of any kind on this machine. So I can't move the spindle up and down. I have to feed the table up and down all the time. So what we're going to do is we're going to touch off anyway. We're going to set our height, zero it out on the Z axis on the DRO here, and then what we'll do is we'll put a cut on and we'll get going. Alright. Oh, I haven't got the... There we are, forward gear now, well, full high speed gear, fast speed I should say, and I'm bringing the clutch lever forward as well. You can hear it reset the panel there, so it's ready to go. Alright, here we go. We're going clockwise direction as well. Okay, what I'm going to do now is I'm going to lock the table in position, so I'll just bring you out so you can see what's going on. Alright, what I'm going to do now is I'm going to put a cut on. I've zeroed the Z axis on the DRO. I'm going to put a cut on. I'm going to go down, because this is a metric width bar, I need to, because it's 8mm thick, to tie up with the other parts of the fabrication. I'm going to have to cut 6mm out of this. So I'll need to put on 236 thousandths, which is 6mm in metric. And I'll have to do it by feeding the table up. It's actually in millimeters here, it should be in inches. I think that's better. 2.36. There we are, getting closer. Let's just verify that by converting it back to metric, well 5.995, that's good enough. I say it's only for fabrication purposes. Once we've welded everything up, and we can start applying some precision. I'm happy with that. So that's now. So what I'm going to do now is I'm going to lock the knee in position. I don't want it to move up, down, or whatever. I have to lock it there, and on the other side too. There's 2 bolts, one either side of the knee. Okay, what we're going to do as well is, I've got it centralised where I want it now. I'm going to lock the Y-axis. Okay. Now, I'm going to bring you in a bit closer and we're going to see exactly what happens here. You'll see the chips. They actually throw the chips out quite a way. It's quite impressive to see. These are the type of cutters that they use on the CNC milling machines and things of this nature, where you've got big high horsepower motors, you've got strong, rigid, well-built machines, and you've got maximum speeds and feeds to get maximum production out. And these things, they're designed for chip evacuation. So you'll see the chips coming out. We can't achieve the speeds and feeds that you can on a CNC machine. So we've got to slow things down a little bit. But nevertheless, it'll still do a good job. These are excellent cutters. Right, let's get going. I'm going to bring you in a little bit so you can see what's going on. Alright, so you ready? Everything's locked. The only thing we're going to feed now is the X-axis. And I've got it in manual here. Okay? That's it. That one's done. You can see how I moved the swarf there, the chips come straight to fly out. Imagine if that was running a lot faster with faster feed rates, with chips going everywhere. You definitely need coolant supply and things like that. This machine is fitted with coolant supply, but I haven't got it connected up. I've only got, in the panel behind, there's the 2 inverters for the main drive motor, which is in the base, and the carriage traverse feed motor, which is just below you actually. But anyway, there we are. That's the first one done. We're going to move around to the next one. We're going to cut that. Can you still see all right there, or do you want me to move you? I'll move you to the other side, eh? Okay, is that better? Yeah, I think you can still see okay there. Right, what I'll do is I'll whiz this round to the other side. go. Set that. Just get that cutter so it's in the middle thereabouts, and we'll lock the table. Absolutely essential that you lock the table, certainly using these cutters, because they will just chew into your work if you're not careful. These cutters are designed for maximum metal removal. They're really good. Alright, so the only feed that's not locked is the X-axis, and that's the one that we're going to be working with. Okay, you ready? Sweep up. I don't like the swarf accumulating around the work. You see by the colour of some of the chips they get quite hot. Okay, and there we are. Right, I'll just move you out the way. Now I'm going to turn this over. I'll clean the burrs off first. We'll turn it over and we'll do the other side. Just want to show you something on this vise on the milling machine here. When you put something in the vise and you want to put the parallel up against the jaw to hold the work, you can't on this particular vise, and I've seen that a lot on more modern vices. This is rough cast, it's not machined. Obviously they've done that so that there's still a radius or something in the corner, so you don't get a sharp corner. When you have a sharp corner you'll get stress rises and you get fractures taking place. So they don't machine right up into the corner. But in the old days what they probably would have done would have been to have the jaw so it overhung that radius or that cast bit. But they haven't done that in this case. So what you have to do, I mean, you could make a thicker jaw if you wanted to, which would step that out. So I put a block in. If I've got a piece of work that's thin, I put a block in first, and then I'll put that parallel in, because can you see how thin that parallel is? It's about 1/8 of an inch. So that would just, if I wanted to put something up that's sitting on the cast now, that's no good, that's crap. So you have to put a piece in, put that in, and then your work will sit on top like that. Yeah. So you have to be a little bit creative with things like that. Anyway, let's get this thing done. You can see they were the two sides that we machined. You can see that, can't you? Yeah, so we'll put them in. That's not supposed to happen. Let's just close that down. I'm going to zoom you out as well. Get a better picture then of what's going on. You can see a bit more now, can't you? That's just going to sit down on top, that parallel. Pinch it up with this. There's my tapping stick. Yeah. You don't need to break hell out of these things when you're clamping them down in the vise. You've got to make sure that they're down tight on the parallel. Obviously the normal way of doing that is to give a tap and then feel the parallel. If it moves, it's not down properly. If it's not moving, it's okay. But make sure it's tight. Yeah, you can hear that was solid then. Right, so put that down there. Let's move the handle out of the way. To that side there. Right, as we earmuffs on my glasses. Right, are you ready? Well, this is still set at 236, so we've got our depth already set. All we've got to do is cut in. So we'll just move that along. Right. We'll lock the... Let's bring that a bit further out. That'll do. Let's lock the table, as we normally do. Make sure you got your glasses on. You'll need them because the stuff's going to go flying all over you. Right, just put that there and hopefully the crap will go down there. Right. Let's put it into high gear. Release the brake and the clutch. Reset. Forward. Clamps on the y-axis that allow me to traverse across and just clean the back face up there. Get it nice and square. Alright, well there you are, that's a little demonstration of the use of the universal milling machine. Just doing a simple component part of a fabrication. No accuracy required on this, but it'll just give you an idea of what was going on. And you can see this quite a these are very useful cutters, the router cutters. So you can see what they're used on CNC machines. They're just chewing to work, no problem at all. Like I said to you just before, if you're using them for down milling, be extremely careful. Extremely careful. They will just bite straight into the work, no problem at all. And just chew it away. But anyway, there you go. That's the job done. I think that was pretty good for first video with using the machines themselves. We'll try. What I'll do is I'll put a video together and I'll see what it looks like. If it looks all right, we'll get it posted on the YouTube page. But anyway, thanks for watching.